Welcome back to Contextual Electronics. This video is going to be about using Netclasses for your layouts and all of the things that it entails. So to do so, we need to open up the KiCad project. We're going to use the example project. I did preload this with a couple of just simple passive components, and they should be also associated with some 0805 components. Really, the components here are not important. It's more the net names and the what they're connected to. So let's just double check in the CVPCB just to make sure. Yes, they're all associated properly. Okay, let's go into the PCB new. Okay, and we'll import these components. And like usual, we'll move and place these. All right, and let's spread these out. There we go. Okay, so we can see that they do want to connect each other with the rat's nest. What we can also see, well, I guess that's really it. We can see the net names as well. What we want to do is change our design rules. First, let's change our global design rules, with our minimums being outside of 20, inside of 13 mils. And then this has to get a little bit smaller as well, or else it'll give us an error. And then let's add in a couple of diameters and drills. 0.013. Okay, let's do 0.046, 0.024. And then we'll make this 0.016. 0.024. Okay, so these are our minimums allowed, and these are our customs, which we've gone over before, what those do. Now, what we want to do is we can see we have a list of different memberships here. Well, what we need to do first is actually add a class. So let's do that. We'll call one power. We'll call the other signal. Okay, and now we can see that these pulled up the same defaults as we have anywhere else, which are bigger than the minimums. So let's call power. Let's make this a larger trace. Oops. Oh shoot. Sorry. Didn't save anything there. Luckily, it's not hard to add these. Okay. So power, let's make this a track size of 30, or clearance rather, sorry, 15. Track size of 30. And really these are pretty arbitrary. Make this 50. Make this 35. That's nice and big. And then this one will say keep the clearance at 10, track width at 10. Via, let's go to the minimum that we just defined before. Drill 13. Alright. Oh, it probably has to be smaller as well, so let's match the other minimums. Alright, let's hit OK, make sure everything... Aha, it didn't like that still. It didn't like... it didn't save. So that's from before, when I hit escape by accident. Alright, how about now? Yeah, that worked. Okay, so that's a good way to check as well. Alright, so we have our net classes. Now what we want to do is actually add some of these signals into the different net classes. So let's do a pull down here. We'll make this the power side. So this is the 12 volt. It didn't, I guess the net name didn't take, but we can tell it's the only one left. So we'll add that one, and then the ground as well. Then we do the pull down, go to signal, and then we can add in these as signal and signal. There we go. So we have, these are all the any's, and then we have different nets and different nets within the membership of signal or power. Alright, so what does this mean for us? Well, let's actually start drawing a trace on the top side layer. We can see this is the R2R, and it did default to 10 mils. Oh, that's not the right trace. This is connecting down here, actually. There we go. Now, if we want to then switch to ground, this is the power group, and we can see it did default to the larger size. Also, it should default to a larger via, which it did. And then we can finish that off. We should see a smaller via on this one. And there it is. So we have a smaller via on the smaller track, and basically everything matches up as how we expect it to, which is great. Now, the other question here is, what if we want a different or custom size trace? Well, if you remember, we did that as well, and we can do this the same way we do it in other cases. We hit W. Oh, shoot. Sorry. When I wiped it out before, by accident, it didn't take. So this will ruin the surprise, but if we say this is 0.014, 0.02, now we can start drawing, hit width, and we can actually change the segment dynamically, including within segment. So we can make certain parts of the segment wider or skinnier than the other, basically just by hitting the W key. And there we go. So we can change custom widths or track widths. We can have net defined track widths, or we can have net defined vias. Now the other thing to do here, I'm going to wipe out this one. The other thing to notice is actually watch this region down here, because as we do a signal that pops up as a net class name, we can see down there net NC or net class name, clearance, width, size, via drill, and then more information that's standard about that. So it's great because now that we actually put it into that club, into the net class for signal, it not only accepts all of those different parameters, it also shows them to you so you can tell. And so that's a great way for you to be able to segment. Say you have memory signals that you want to be, a certain trace size or something like that, or you want the vias to be different. You can define all those before you actually do any routing at all, and it can be really useful for your layout so that you have a uniform looking layout with a bunch of standard signals and such. Now another thing to note here is that the clearance is also it is also showing here, and that's what is going to prevent you from, I'm clicking right here and trying to place signals, and it actually won't let me because of the clearance. It actually is snapping so that it's trying to get around the signal here. I can't do that because it's crossing, but I could do that. It actually does. It snaps to the closest available distance, and then it lets me do that, but it doesn't let me do illegal operations like crossing over, which is great. So, Netclasses are a wonderful tool in order to, help you define your different signals in your design, and to help you make a cleaner looking design and make a design faster than you would be able to otherwise. Thanks for watching.